Okay, well, good morning, everybody, and welcome and thank you for joining us today. We'll be spending about an hour together, and we want to make sure that this time is productive for you and hopefully informative. So, this morning, Automation Distribution Incorporated and B&R Automation are going to spend some time going over the ACOPOStrak solution. This webinar is designed to deliver an overview of the technology as well as its application. The goal is to try to stimulate some thought on how the solution can improve productivity and profitability in your organization. We'll go over the agenda. We'll go over the format for today's call, and there will be time for questions at the end. We'll begin today with a brief introduction to automation distribution. We'll give an introduction to our presenters. They'll present an overview of the solutions that B&R provides, a live walkthrough demonstration. We'll see some videos of application, and then we'll answer questions that'll come up through the course of the webinar. We'll be following up with each participant individually in the coming days as well, if there's any further discussion and questions that you may have. So again, thanks for joining us, and we're looking forward to spending some time together. My name is Phil Marchese. I'm the COO at Automation Distribution, and we are an automation solutions provider, primarily working with clients in the factory, material handling, life science, and food and beverage industries. Our goal is to help you meet your automation needs with cost-effective technology solutions. We provide a wide range of services to help you really in any way that we can, from simple component sourcing and kitting all the way up to prototyping, production, and programming services. We have a website that is a convenient source for product information and easy purchasing. There are search and filter functions on the website. It offers you 24/7, 365 access to everything we have to offer as an organization. Our process is driven towards your needs. We basically look at our role as being an outsourced solutions provider for your organization. It starts with getting a sense of your project, your process, and your particular challenges. We then conduct an on-site review and take a look at what kind of production demand there might be and what kind of budget is available for any particular application. We then go to work in building a solution and presenting that solution to you. And from there, our job is to make sure there's a smooth implementation and ongoing support to meet your needs over the entire life cycle of the automation implementation. Sorry, my finger is moving too fast on the screen there, and we're going over the slides. Today's agenda and format. We're going to have a live stream. Participants should all be on mute. We will have the ability for you to submit questions at any time during the presentation. You should direct all chat questions to the organizer, and we will have a portion of our webinar at the end where we'll answer as many questions as possible, time permitting. We've already gone through the introduction to automation distribution. So now I'd like to present today's webinar hosts, Nathan Massey and David Emery from B&R Automation. Nathan is the Northeast Regional Manager, and he's a tenured and degreed engineer from Georgia Tech. He has served B&R well in terms of both developing product solutions, developing end markets, and providing customers with solutions to some of their most challenging automation needs. David Emery is the Director of Track Technologies at B&R. He is the go-to source for all customer questions, as well as implementation and ongoing support opportunities for B&R. He's a graduate of Iowa University. Today, we're going to cover the capabilities and advantages of ACOPOStrak versus traditional conveyor and other conveyance solutions for merging and dividing product flows, improving availability and fault tolerance, parallel processing, scalability of the solution, and in many cases, the opportunity to significantly reduce footprint. So with that, I want to turn it over to Nathan Massey from B&R.
Hello, good morning, and thanks everybody for joining me today in this virtual format. Hopefully the audio is coming through fine, hopefully the video is coming through fine. Phil, thank you for the introduction. I'm Nathan Massey. I'm the regional manager for B&R, responsible for the Northeast region of the United States. And what we're here to talk about today is track technology. What is the goal of the discussion today? I kind of wanted to talk about that before we jump into the slideshow. So typically when we've done these presentations, these discussions on track technology, normally about halfway through, the engineers and salespeople, they start mentioning, well, what about this machine? What about this problem? What about that application? And it typically leads to open discussion and some whiteboarding and a lot of different ideas and applications and ways that track could potentially be used. Unfortunately, I think this virtual format may not lend itself as well to that. So what I'd ask you to do is if you do see anything today that sounds interesting, it could apply, maybe it doesn't, maybe it does, you're not sure, let's set up a follow-up, a discussion. Let's get together online and do a little virtual whiteboarding with whatever questions you have. So, so with that in mind, I'm going to switch over to the presentation and turn my webcam off quickly. Give me just a minute. All right, so at this point you should be able to see my slideshow. Again, we're here to talk about track technology. So I thought the first thing I should do is maybe show a quick video, because some of you may have seen videos online, some of you may have seen this technology at a PAC Expo or another trade show. You may have seen some of our customers with actual applications where they're using this already in production machinery, but some of you maybe haven't. So I'm just going to play a quick video in the background, and this will help visualize what we're going to be talking about in the next few slides. So you can see this is our track technology. This is actually ACOPOStrak that we're looking at here. So you can see the shuttles going by on the rails, and so just wanted to give you a little bit of a visualization. Now let's jump into a little bit more. And there are actually two different products. We have SuperTrack, which is kind of the big brother of the ACOPOStrak. So we have two different products that utilize the track technology. SuperTrack is in its third generation. It's got more than 15 years in production. It has a higher payload, higher precision, and then ACOPOStrak is based on the same technology, but it's a newer product in the product line, more dynamic, more flexible, and it's also the world's only track with high-speed diverters. So what we're going to be talking about today really applies to both tracks, both track technologies, but we are going to focus a little bit more on ACOPOStrak today. So a little bit of the basics. What exactly is track technology? So ACOPOStrak is the flexible transport system that enables adaptive manufacturing and more efficient production. So this is based on long stator linear motor technology. It's really the same technology used in the standard servo motor, but the circular nature, the rotation of a servo motor has been opened up to allow it to be controlled in a linear fashion. So each shuttle can be controlled individually and moved along the linear track that we're looking at here. If we look a little bit closer at the actual technology and the functions behind it, it's actually fairly basic. So there's permanent magnets on the shuttle. The permanent magnets are what's creating the force holding the shuttle to the track. And then in the track, which is the stator of the servo motor that we're talking about, there's a series of coils. And by controlling the current in those coils, we can move the shuttles individually forwards and backwards along the track. So what are some of the features of this track technology that allows it to be so beneficial to production applications and manufacturing? One, like I said, is that every single shuttle can be controlled individually. This means that every product that's on the shuttles can be controlled individually. The processes that they go through can be customized, and you can really have high-speed, efficient production at any batch size, even down to batch size of 1. Another very important feature is the flexible track design. So as you can see in this video, with just a few components of track, we can actually make a very scalable and very flexible machine design, as opposed to having to create the machine design around the transport system. You can see in this example here, we've got different guides and segments that you can use to build up a complete system. You can have more than 100 meters of track length, more than 250 shuttles, so you really have a lot of flexibility in the manufacturing design. High-speed diverters. ACOPOStrak is the only track system in the world that has high-speed diverters. And we can look at what that looks like here. So the coils, as the shuttle is going in between two segments of track, the coils can field weaken on one side and strengthen the field on the other side to cause the shuttle to move from one track to the other. So with that, we can change the direction and change the track that the shuttle is on at full speed without having to slow down, fully electronically. So no moving parts, no mechanical parts are required for that merge and divert. This also means the merge and divert is completely free of wear and maintenance because there's no mechanical parts. Hot swappable shuttles. So while the machine is running, while the machine is powered up, shuttles can be added and removed. This allows for example, if you need to change the tooling on the shuttle. So the tooling that's actually holding the product or the products or the batches that are on each shuttle, those can be changed out on the fly. For example, you could have a pit lane in the track design that allows certain shuttles to come off, be exchanged, and then move back into production. And actually in one of the demos we're going to look at behind me, we'll actually see an example of this hot swapping. Maximum productivity. So we've designed this track to have a minimum pitch, so you can stack as many products as close together as possible and maximize the speed and the acceleration and deceleration so that you can get the most amount of production from the least amount of space. We see what some of those numbers are here. The minimum product pitch is 50 millimeters. speed of 4 meters per second, and acceleration up to 5 Gs. So really a very highly dynamic transport system. There's a common DC bus, so power can be shared. So yeah, as I was saying, in addition to the speed, acceleration, and pitch, we have a common DC bus, so we can share power on the system while shuttles are accelerating or decelerating. And also we can change the orientation of the track. So we can have it horizontally like the video we saw at the beginning, but we can also turn the track vertically, and we'll see an example of that shortly as well. Another important feature of the track is the repeatable precision. So you can see here in this example, we're coordinating motion of a robot with the track, and we have precision with our track technology, repeatable precision down to 10 microns. And we can also do production, as you're seeing on the video here, on the corners, on the curves of the track as well, which is another important thing that allows you to shrink the footprint of the track by utilizing processes on the entire length of track, including the curves. Washdown design is often very important in a lot of the applications we look at. Natively, the track is always washdown. The ACOPOStrak is IP65 rated washdown. We also have a new iteration of the track coming out, which will be IP69K, high pressure steam washdown. So then that version can even be incorporated into hygienic applications as well. The software behind the track is just as important as the hardware. So let's talk a little bit about that. Really the way the track is programmed is based on the manufacturing process. So you can define where different processes, for example, filling, capping, labeling, are going to occur in the system. And then you simply tell the track when its process is done and tell the shuttle to go to the next process point. All of the buffering, all of the path coordination, all of the collision avoidance is handled natively by the system. So what you're not having to do is program individual shuttles, individual collision avoidance, worry about where the shuttles behind and in front of your shuttle are located. All of that is handled natively by the software. We also have a digital twin integrated simulation. As you can see on the screen, this is an example where we can program the track without actually having any of the hardware present. So this means we can simulate the entire process, including all of the different components of the manufacturing process. And then that same code, that same software we used for the simulation can then be applied to the actual system. So now we've talked about some of the features. How can we apply that? What are some of the ways, some of the advantages in the actual application that we can use those features? So the first one is merging product flows. So we can see an example here where, let's say, we have multiple packages or multiple processes that we need to do in a system, and then we need to merge those together to create maybe a rainbow configuration. So here, this could be, for example, a packaging application where we're doing a rainbow pack, and we can customize every single package to exactly what has been defined by the customer or by the order. Another example would be dividing product flows. So in this example here, we have an integrated camera that's looking at every product as it comes through the track. And we could be detecting, for example, quality issues, or maybe certain products that need to go back and be reworked. Those can be identified, and those can be divided from the standard product flow, so they're no longer taking up space or process points in the process. Improved fault tolerance. So here we're going to see an example of a capping application where we're processing two different types of caps in parallel. And what we're going to see is that one of our capping stations is going to go down. For whatever reason, we had a capping station go down. We can hold off on that one position in the capping process, but continue to process the rest of the product. In a typical conveyance system, for example, a feed screw, you wouldn't be able to do that. You'd have to continue to populate every position in the capping application, which means you'd be wasting product, wasting bottles, wasting caps, and then having to rerun all of the bad products back to the beginning. With Track, we can change that on the fly and simply omit a single section, a single station of the process. Parallel processing. So here we see an example where we're in the manufacturing process. We have 4 stations, but one of the stations on the left side takes much longer. So we can duplicate that, or in this case, we have 3 stations running in parallel so that we can increase our throughput without having to duplicate any of the stations that are able to run much faster. So we have 1-up processes and 3-up processes in the same manufacturing line. Scalable machinery. So because of the way the Track design is designed, it's very easy to expand and grow the Track system even after it's been installed. So you could have a production line in the field and even add on to that additional segments or even additional track loops and diverts and pit lanes after the system has been installed. So you can really scale the machinery both in production and in the field to fit the application. Another very important use is interlinking this with standard conveyors. So utilizing the performance of Track where we need it and the cost efficiency of conventional conveyor where we don't need it. So here's an example video where we see the product coming in on conventional conveyor, and then when we get to the manufacturing process, switching to ACOPOStrak so that now everything can be controlled individually. And then we can go right back to conventional conveyor where we don't need that synchronization or that precision. And finally, integration with CNC and robotics. This isn't always required, but sometimes robots are being integrated with the rest of the manufacturing process. And with Track technology, we can integrate that directly and coordinate our motion of the Track with our CNC or our robotics. So here we see another application where we're using a robot to perform a certain process on the Track while the Track is moving. Excellent. So I know I kind of ran through a lot there. We're trying to fit a lot into a very short amount of time. I did want to mention this as well. So Keith Jacobs, if you're not familiar, he's actually the one of the inventors of the iTrack, and he got a chance to see the Track. He's actually seen it many times, and he actually made this announcement after the ACOPOStrak was released and presented at the SPS show a few years ago. And he said that he believed that the ACOPOStrak is the 2nd generation of independent mover technology because it's brought together elements that those who pioneered the technology dreamed about years ago. So a pretty a bold and pretty positive statement from one of the original inventors of Track technology.
What Nathan has asked, my name is David Emery, I should say that. Dave Emery, I am the director for the Track technology and for end user focuses. What I like to do is put a little practicality to what Nathan said. It was it's a great feature that we can walk through the demo demo area, and we've invited everyone. Once we're all out of this quarantine stuff, we can come down. You can bring customers yourselves, and we can help run through all kinds of different scenarios with our test equipment there. What I thought I'd do is I have just 4 kind of practical applications that we thought would be some good time for you to see. I'll start with a collaborative application that we've done with ABB. Phil's everything showing up okay there?
Yes, sir.
Okay, wonderful. So what you're seeing here, guys, is the ABB collaborative demo. It's a snack creation. This could be just about anything in terms of how products are being personalized, right? It's an adaptive machine, so it's able to adapt to requirements. It can be single batch, or we say batch 1 now. I like to use personalized production as well. I think that it's important to note that the robot types are really independent here. So you have Scera, you have the Yumi, which is a collaborative robot. You have any of our IRB type robots, overhead robots, large scale, all working in conjunction with our track technology. Currently, this is all controlled with, the track is controlled with our B&R controller. The robots have their own controllers. We will be moving forward and are moving forward already with technology so that this could be a single control, a robot-centric, machine-centric, robot-centric controller. So that's an exciting piece as well. I guess the point, or another point here, I think, is to make the multiple robot types working in conjunction with ACOPOStrak in this case, but it could also be SuperTrack. So next, I'd like for you to see another practical application. This is a running application. This is an interesting story. This is a lab in Denmark, funded by a large shipping conglomerate called Maersk. They have a lot. They're very, very diversified, but they they donated a lot of the dollars here for this. But this was done by a group of students, actually procured and assembled and programmed. It's hard to tell from here because there's the next stage, but they're going to be creating drones here. So they're going to actually do drone production, and you can see the accumulation stations that came in phases. It's very interesting to note, though, I suppose, that this was all done with students. Of course, we monitored it as B&R and helped them. Next phase will be the implementation of robots and assembly stations. But ultimately, this will be producing drones, and we're going to document kind of how this goes, because this is all public information available, YouTube and LinkedIn, etc. But this Maersk lab has done a wonderful job in creating a natural production. And I think it's interesting to note here how easy it is to assemble in terms of, how, if you can see how the comms and power are all daisy chained. That's an important point. It's simple, it's elegant, and it was expandable, meaning that the far-sided loop was just added recently, and it was added with very little difficulty in terms of other than space. They needed the space, but they were able to then add the code, simulate it before they added it, and then put actual hardware, and all done by engineering students. Very, very cool, I think. Another important note is that they plan to use the space internal to the loops to mount robotic assembly stations and such. So they're going to be using what they can in that cylinder without having to expand the footprint. So there's your footprint save. Next, I'd like to show the an OEM in Italy called Ronchi. What you're going to see here is an interesting application. It's a bottle descrambler or unscrambler. There's several points I'll stop during the process here because it's an interesting. There's interesting points that are difficult to see. I'll stop here just because I want you to remember that what you're seeing below deck, if you will, there is a 45 degree angled planer, so that this, as Nathan mentioned, these tracks don't have to be in an XY plane. They can be in varying degrees based on application. In this case, 45 degrees was needed. I'll go ahead and show some more here. It's important to note they're also integrating robots, multiple in this case, as you can see. I'll probably stop it there and back it up a bit for you. I want you to note that right around here, you'll see that the point of this, sorry, is that it's multi-format unscrambler, meaning currently we'll just say blue bottle. If you keep an eye on it, the application right around there clamps the bottle, and there's other points where I'll show you, but excuse me, they're using that and integrating vision into this to tell you it's blue bottle, but they're using the shuttle actually as the clamp, so tooling does not need to be changed to modify format, meaning going to the next bottle. The integrated vision allows you to tell what it is. This is a good example of what the tooling looks like. Nathan mentioned hot swapping, so this is an application where they wanted to do maintenance on certain shuttles, and we track that in the code actually, so we can tell you how far each shuttle has traveled, and then you can modify maintenance programs based on that. Again, robots are orienting, so I think this is a good example. As we place this bottle, you'll see the shuttles clamp. There it is, so that that clamping tool does not need to be replaced. In a little bit here, you will see a quick changeover, and I'll explain what they're doing here. Here's another example of how they do it. You can see those shuttles diving off there. That's the 45. So there's the 45-degree angle. That was important to note because that allowed this machine to be a lot shorter and a lot more compact. The operator now is just using a menu-driven HMI to go blue bottle. I want to now run white bottle. Let's just say completely different format. The machine will empty and cycle, and then you'll see a format change. And the bottle can run on this exact same machine. So now we have a different bottle. Maybe it's the same material entering the bottle, maybe it's not. But either way, it's a different format. It can be a different piece of equipment altogether. And the track facilitated this. So there you have it. Those are some of the practical examples that we wanted to bring to your attention. At this point, I think I will hand it back to Phil.
Thank you very much, David. That was a great overview. We have not yet had any questions submitted, so at this particular time, I'm going to just spend a couple of minutes going over an overview and encouraging everyone as sort of a last chance here to submit any questions that you might have via live chat. And as a reminder, we want to submit those questions to the organizers. Just to highlight some of the things that Nathan and David talked about today in terms of the SuperTrack and ACOPOStrak solutions. Those particular technologies give us a high degree of precision and repeatability, and they allow configurability. In other words, you can customize both the accumulation and the conveyance, and basically you're creating product customization and personalization. They offer rapid change of line, reducing downtime. The shuttles are hot swappable. It's a dynamic system that can be expanded or shrank to meet variable demand in production. There's a reduced footprint versus traditional conveyance. There's integrated collision avoidance. And B&R has a fantastic digital twin simulation tool that allows you to do programming and troubleshooting before you ever even hit the ground in a physical installation. We really appreciate the time that Nathan and David put towards organizing and presenting today. We are fairly new in terms of our partnership with B&R Automation, and the automation distribution team has been very impressed with the technology that B&R offers, with the support, with the knowledge, and with just the general ease of working relationship across the entire B&R organization. After today's webinar, we will in the coming days follow up individually with each participant. If you have particular questions after thinking a little bit more on what you saw today, you can email info@automationdistribution.com to schedule a further discussion. And you're always free to visit our websites to learn more, automationdistribution.com and B&Rautomation.com. We want to thank you for joining us today, and keep an eye out. There will be additional webinar events happening, and hopefully over the course of this year, we'll have the opportunity to have some additional live and in-person events as well. So thanks again for joining us. Stay safe and stay healthy.